Hello class, and welcome to lesson 4.0b, comparing relationships. Today we're going to be using the TID3 again, and you could use any graphing calculator that produces a table to help you with this, as well as any graphing app on your phone or on your iPad. All right, so taking a look, folks, today again we're going to be using the technology option. So we're going to be putting our equations into y equals like we did last class. As well, we're going to be pressing graph to see what the graph looks like. And instead of creating the table of values yourself, which I'll show you how to do it manually, we'll also be using second graph to get the table of values up. All right. So first of all, ladies and gentlemen, we're going to start with investigation 1. Looking at this equation, can you tell me if it's linear or nonlinear? Well, hopefully you know the answer that this is a linear relationship. Why? Because there's no visible exponents, okay? And it looks like it's in the form y equals mx plus b. All right, so what we're going to do is use our graphing calculator. I've already reset it, folks. I'm going to go to y equals, and I'm going to put in 2 xt theta n, and I'll just clear that and put that in the right. I'll go up to y1 and go 2 xt theta n, and I'm going to graph it. Okay, so it's a straight line. We were correct with our analysis, linear. Now I'm going to go to get the table, which is second and graph. Okay, and I'm going to use my arrows up and down to make sure I get the top, which I want is -3. Okay, so those are the values I'm going to enter in on my lesson. So I'll click back to my lesson, and I will go -6, -4, -2, 0, 2, 4, and 6. All right. So ladies and gentlemen, we can do the first differences first, okay? So taking a look, remember for your first differences, I'll show you the first one. It's the lower subtract the upper, if you're not sure how to do this, because it might have been a while. So 6 subtract 4 is 2. 4 subtract 2 is 2. 2 subtract 0 is 2. 0 subtract -2 is 2. When you subtract a negative, it becomes a positive. -2 subtract -4 is 2, and -4 subtract -6 is 2. All right. So let's graph this, ladies and gentlemen. Whenever we have a graph, don't forget to label your axes x and y. Put at least one marker on for your scale on each axis, positive and negative, please. Okay, and then you can plot the points like we did before. Okay. So I start here and I got -3 and -6 down here. Okay, or I could plot the other points, -2, -4. I could do that, or I could use the short form way of graphing this. Remember, y equals mx plus b, my b equals 0. Okay, so I'm going to start here. And from there, I'm going to do the slope, and the slope equals 2 over 1, right? 2, which is 2 over 1. So from my y-intercept, I'm going to rise 2, run 1, rise 2, run 1, rise 2, run 1, and you can follow that pattern all the way along. Okay? Grab a straight edge, ladies and gentlemen, and we're going to join all our dots to create a line. Okay, I'm just going to change make sure you've got arrows on both ends, folks. And we're also going to label the equation. Okay? So we're going to label the equation y equals 2x. All right. Let's answer the blanks down below. The first differences are equal or the same. Therefore, this relationship is linear. Hopefully you remember that from grade 9 as well as what we've already done this year in Unit 1. The graph of this linear relation creates when you graph it, a straight line. Okay? The general equation for a linear relation is y equals mx plus b. Okay? Where there are no visible exponents. Okay. Let's just quickly review, folks, 3 ways we can graph a linear relationship. First is table of values. Okay. Second method is slope and y-intercept. That's where you use the b and the m. And the third, which is less common that you might have forgotten, is x and y intercepts. Remember, to find the x-intercept, you let y equal 0, and to find the y-intercept, you let x equal 0. Okay, so if I look on my graph here, the x-intercept would be 0, and the y-intercept would be 0. So it would go straight across there. Okay? All right, ladies and gentlemen, I want you to back up for a second and say, I want you to remember, how do we find these y values or the dependent values if we don't have the technology we had? I just want to remember that manually, if you didn't have a graphing calculator, how would you get these values? Remember, you're going to substitute in x equals -3. So I'm going to rewrite this equation and go y equals 2 times -3. So y equals -6. Okay. Likewise, I could sub in x equals -2 for a sub in. So y equals 2 times -2, y equals -4. So that's how you would do it manually if you didn't have the graphing calculator. Awesome. Now we're going to do a summary, and I'd like you to put these summaries in boxes and star them. This is your key things I want you to remember from this unit. And when we get to unit 5 and 6, probably more unit 6, we will be assessed on this, okay? So let's take a look. To summarize a linear relation, the graph is a straight line. The table of values, the first differences are the same. And the equation has no visible exponents. Awesome. Let's go take a look at another relationship. Investigation 2. Take a look at this equation that we have here, ladies and gentlemen. Okay, this is y equals x squared. Okay, so do you think this is linear? No, it is nonlinear because it has a visible exponent. And it has an exponent of 2, so hopefully you know that this is a quadratic. So hopefully we're going to take a look at a U-shaped curve, kind of like we did in last day's investigations as well. All right. So let's go to the graphing calculator, folks. Let's go to y equals. Change our equation, so it's going to be x, and so I have to press x, t, theta, n, and then the x squared button. Okay, now I'm going to press graph, and we got a nice parabola there. Okay, so we're going to, ladies and gentlemen, take a look at the table of values. So to find that, I'm going to go second and graph, and then I'm going to enter these values 9410149 into the table in my lesson. So we said 9410149. Okay. Now we talked a little bit about quadratics, folks, and that there'd be a maximum or minimum. Look at the patterning here. We got 9410149. There's a turnaround point. And the turnaround point is right here, folks, and we're going to call that the vertex. So it's the vertex of the equation. Okay? All right. And so now that we've got our values, folks, let's do the first and second differences, and then we'll graph it. Okay? So let's do the first differences. So 9 subtract 4 is 5. 4 subtract 1 is 3. 1 subtract 0 is 1. 1 subtract 1 is -1. 1 subtract 4 is -3, and 4 subtract 9 is -5. So the first differences aren't the same, so that means that it cannot be linear. That's what we suspected. Let's do the second differences, folks, and see what happens. So the second differences is taking the differences of the first differences. So before you've seen delta y, change in y, this is going to be delta y, if you're wondering about the terminology for second differences. So 5 subtract 3 is 2, 3 subtract 1 is 2, 1 subtract -1 becomes a positive is 2. Okay, so your patterning is 2. Now we're going to graph this parabola, folks, so make sure you put your axes on, label your scales. All right. So I'm going to start at the vertex, and I'm going to show you a pattern. So vertex is the one I've circled 0, 0. Okay? And I would like you to write down, this is the base equation for a quadratic. Okay? It's as simple as it's going to be. In a lesson or two, we're going to be taking this base quadratic, and we're going to be shifting it left, right, up, down. We're going to stretch, compress it, and we might even flip it upside down. So we'll have lots of fun coming up with that. Okay, but today we're just taking a look at different models. Okay, so to graph this, I'm going to go with my positive ones first. I'm going to go 1 and 1, 2 and 4, and 3 and 9. 1 and 1, 2 and 4. My fault. I put 2 and 3. And 3 and 5, 6, 7, 8, 9. Watch when I do the negative ones. Negative 1 and 1. Notice that they line up. Okay, negative 2 and 4. Notice those two line up. And negative 3 and 9. These are symmetry points. So this one and this one are symmetry points. This and this are symmetry points. And this one are symmetry points. Why? Because they're equal distance from the vertex. So if I draw my diagram, this is my parabola, and I'm going to label it y equals x squared. And there's a point of symmetry here called the axis of symmetry. I'll just introduce it to you now. Right along the y-axis. We're going to get to this, but this is the axis of symmetry. Okay? And with any parabola, the vertex is on the axis of symmetry, and every point to the left of the vertex has a matching point on the right. And it continues and continues. That's why the arrows keep increasing. All right? So again, we now know the vertex. So one piece of terminology, the axis of symmetry, and we've learned about symmetry points. They're equal distance from the axis of symmetry. All right, let's take a look at filling in the blanks here, folks. The first differences are variable or not the same, whatever you want to write down there. And the second differences are constant or equal. Therefore, this relation is quadratic. Okay, the graph of this quadratic relation creates a, what shape is it called, folks? It's a parabola or parabola. Most people call it parabola. Okay, the most basic equation for a quadratic relation is y equals x squared, which we have here. Okay, and then remember I said we're going to be shifting left, right, up, down, stretching, compressing. We'll learn all about that fun stuff in another lesson. Okay, now ladies and gentlemen, this is a review of quadratics, but I'm going to put every form of the quadratic in a nice box here. So by the time you're studying this for Unit 6 test, you will have gone over these in class with the algebra, learning how to shift each form from one form to another. So it's going to be here. I want you to put it down now. I don't expect you to know these already, but you will by the time we're done Unit 6. Okay? So the vertex form looks like this. It's y equals a bracket x minus p squared plus q. And it's easy to find the vertex. So we just talked about that vertex point, folks. And the vertex in this formula is the p, comma, q. It's an ordered pair. So we like the vertex form because it tells us the minimum or maximum values. Okay? Standard form, ladies and gentlemen, is common to what you're going to see from before. It's going to be y equals ax squared plus bx plus c. And that's easy to find the y-intercept, or the initial start value, and that's your C value. So remember a couple lessons ago we were talking about the rockets and the skydivers. We could tell their initial starting value because of the C value. So that's one expression, okay? The other, or the last one, is the factored form. That's y equals a bracket x minus r bracket x minus s. And this is easy to find the x-intercepts. Now hold on, leave some room here because x-intercepts has many names. They could be called the roots, or when we use the graphing calculator, we actually use the zeros, or solutions. Lots of names for those. Okay? But if you're looking at a graph, we would call it the x-intercept. All right, so those are something to study for Unit 6, as well as this summary of what a quadratic relation is. So please make sure you got these in boxes. make sure you're going to star these. Okay, so for a quadratic relation, folks, the graph is a parabola. The first differences are variable, but the second differences are the same. And for an equation, it has an exponent of 2 when in standard form and vertex form. So if I look back up here, I'll erase in a minute, but notice the standard form has squared. And so is the standard form. The tricky part about factored form is these are factors and they're going to be multiplied. So if you think about x times x, that will lend you to the x squared. But you just don't see the squared in the formula, but you see 2 x's. So you just think about it. Those are multipliers, so x times x gives you x squared. Awesome. Let's take a look at investigation number 3. Last one, guys. Okay, so go to y equals, before we do that, let's take a look at the equation. Ooh, this is a different looking one. Is it linear? No, it can't be linear because it has an exponent. Is the exponent 2? No, the exponent is actually the x. So can it be a quadratic? No. So we know it's nonlinear. We know it's not going to be quadratic. So we're going to learn what this is. Okay, and I'm not going to tell you. I'm not going to give you a hint. Ha ha ha. All right. So what we're going to do is type this in and take a look what it looks like. Okay, so I'm going to go to y equals. I'm going to change this up. It's going to be 2 to the exponent of x. So that's 2 hat x, which means exponent button, folks. And I'm going to press graph. Look at this cool graph. Okay. Anybody know what this is called? Well, this is actually called an exponential curve. So you might have heard of something like growing exponentially. So if you have an investment of interest, interest gets earned onto the investment, that's called an exponential function. If a fruit fly grows really fast, it grows exponentially. So things like that. Okay, so it starts off small and then gets really, really rapidly big. Okay, basically rumors can grow exponentially. So if one person tells one person, then those people tell 2 other people, those people tell 2 other people, it will quickly go around, and that's why we don't like rumors, right? Okay, so I'm sorry I got off task. There's a tangent I went off on. Sorry. Let's go fill these values in, folks. Okay, so I'm going to start from the bottom, and we had 8, 4, 2, and 1. I'm just going to flip back because sorry, back on I forgot to get the table up. That's why I'm sorry about that. So we'll go second and, hold on. Let me see if I can clear off my ink layer. Sorry, guys. Maybe my ink layer won't go off. Let's see if I can just erase it. That might work. Now try it. So if I go second and graph, okay, I've got my table there. So I apologize, I didn't show you this earlier. So I'm starting from the bottom, and we're going 8, 4, 2, 1, and then we go 0.5, 0.25, and 0.125. Okay? I'm going to start with the bottom ones, like I already did, but then I'm going to follow the patterning. So what's happening from 8 to 4? It's getting halved. From 4 to 2, it's getting halved and halved and halved. So what's half of 1? Half. What's half of a pizza? That's a quarter. A half of a quarter is 1/8. So that's where you're getting those decimal values from, if you're wondering. Okay? All right. So let's do the first differences, folks. There's going to be a patterning here. It's going to be kind of cool. So 8 divided by 4 is 4. 8 subtract 4 is 4. 4 subtract 2 is 2. 2 subtract 1 is 1. 1 subtract 0.5 is 0.5. Do you notice the pattern here, guys? Cool. Awesome. So the first differences aren't the same. That proves that it can't be linear. Let's take a look at the second differences. Because if the second difference is the same, then it's going to be quadratic. Let's see. So I got 2, 1, 0.5, 0.25, 0.125. No, that's not going to work. So we know it can't be linear because the first differences aren't the same. We know it can't be quadratic because the second differences aren't the same. So we do something called the y ratio. If you've got room, ladies and gentlemen, can you write at the top here y ratio? Okay, and that equals the lower value divided by the upper value. Okay, so we're going to do that right here. And that's of the original y values. Okay, so we're going to go here and I'll show you. So it's going to be 8 divided by 4 is 2. Okay, 4 divided by 2 equals 2. 2 divided by 1 equals 2. So notice the patterning, folks. They are going to equal 2. So the y ratio is the same, and this is actually the rate. Okay? So it's doubling. Okay? As we get bigger. So each time we're doubling, doubling, doubling. All right. Let's graph this, folks. So we're going to go 2, 2, negative 2, negative 2. Don't forget xy. Okay? Now, we are going to learn something different. Let's start by graphing the bottom ones first. So I'm going to go 3 and 8. 4, 5, 6, 7, 8. Okay? Then we're going to go 2 and 4. Okay? Then we're going to go 1 and 2. 1 and 0. Okay? And then we're getting in trouble here because we got to go half, and then a quarter, and then an eighth. And so we're getting closer and closer to this x-intercept. But I want to show you what happens if I go to my graphing calculator, okay, and I keep pressing my arrow up. Notice that the y values are getting smaller and smaller. And now they're actually in exponential notation, which is scientific notation. But they're never going to get to 0. Because if you take a half of an eighth, it's going to be what? 1/16. Take a half again. 1/32. 1/64. 1/28. So it keeps going on and on and on and on and on. And we necessarily won't. I'm just going to put it back. So it'll never get there. So there's something called a funny name. It's called an asymptote. So it's a cool math word. We'll define it later in the bottom of our, sorry, went too far now. We'll define it later on the bottom of our sheet here. Okay? So what we need to do with our drawing, folks, so I can put it back there. When we do our drawing, okay, we're going to just keep getting as close as we can. So for here, just go close, 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 and draw an arrow. Don't have it crossing. Okay, the other ones you just swoop up. Okay, and we label it y equals 2 to the x. Okay, the first and second differences are both variable, as we fill in these blanks. Okay, the y ratio is constant. That's probably new for you guys. Therefore, this relation is exponential. Okay, the graph of this exponential relation creates what we call an exponential curve. Some people think of it as a Nike swoosh, but it's not completely like that. Okay? The equation of the exponential relation has an exponent of x. We will examine exponential equations in further relationships. And in grade 11, you have a whole unit on it, okay? All right. So let's take a look at a summary here. We'll do some questions here, and then we'll define that asymptote down below. So save some room, please. Okay, let's summarize exponential relations. So a graph is an exponential curve. The table of values, the first and second differences are variable, but the y ratios are constant, and the equation has an exponent of x. Where in life do we see exponentials in the real world? Well, we have it in population growth or decay. Okay, we have it in investments. So either you're borrowing or investing money. So investments is one. That's where you're putting money in and interest is getting earned. Or say you need to get a loan for school or for a car or for a mortgage. They will also be like that. And speaking of a car, if you get a car, it's going to depreciate. That's just going to go down in value. And that's also an exponential. So depreciation. All right. Now, I want to just define asymptote, ladies and gentlemen, here. Okay. It's funny spelling, too. Ready? Asymptote. Okay. So, that is a line that a curve gets closer and closer. Sorry, my spelling's terrible. Gotta slow down here. That a curve gets closer Sorry, I'll get through this lesson, guys. Don't worry. Gets closer and closer, but will never touch or cross. So just to reemphasize, folks, the example here is for exponentials. It's the y-axis. Okay, so if I draw my graph, and I use the example from above, okay, the asymptote here is this value right here. It's the y-axis. The curve gets closer and closer to, but will not touch or cross. All right, so here's your homework, folks. Complete the handout on comparing relations, which is right here, and your answers, folks, are on the back side at the end, okay? All right, so take a look at doing that, folks. Have a great day, and of course, have some fun with this. If you need any help, please see me, and namaste.